tan, this example, we're going to pretend that we can't even get to the tower. Okay, so this is a kind of a fun example here. Okay, so let's go right here. Going to have a picture looking like this. So here's my tower over here. Okay, so similar to what we just had a second ago. Pretend it's a radio tower or a cell phone tower or wires or something like that. Okay. So, I want you to imagine that if I'm at this point right here, and I look up at the tower, I look up at the top of the tower, I'm seeing an angle of elevation of 47 degrees, 30 minutes. Now, I want you to pretend that I can't figure out this distance. Maybe there's a fence in the way or something. Or maybe there's a road. I'm on one side of the road, the tower's on the other side of the road. I can't measure that distance. Okay, so I still want to figure out the height of the tower, but for whatever reason, I can't get there. So if I stand here and I look up at the tower, 47 degrees, 30 minutes is the angle of elevation. Now let's pretend that I walk backwards. I go back 33 feet, and then I observe that the angle of elevation is 42 degrees, 10 minutes. Okay, now the question is, how high is the tower? Now this is, actually it's a kind of neat idea here. We're going to set up two equations. We're going to set up two equations. Remember, I don't know what this distance is. Okay, I don't know what that is. So I'm going to set up two equations that involve h. And I'm going to solve both of those equations for h, and then I'm going to set them equal to each other. I'm going to set the expressions equal to each other. Okay, so here's equation 1. Once again, we want the opposite side, and we're going to use the adjacent side. We don't know the hypotenuse, so sine and cosine aren't going to come into the picture. We're going to use tangent. Okay, so tan of 47.5 degrees. Okay, remember, if you're going to use your calculator, convert these to decimal degrees. 30 over 60 is the decimal part. Okay, so tan of 47.5, opposite over adjacent, h over x. So we're going to solve that for h. So h equals x times, I guess I really want, tell you what, I'm going to solve it for x and see what happens here. So x equals, I don't know, I'm going to stick to my original plan. I doubted myself there for a second. I'm sticking to my original plan. H equals x times tan of 47.5 degrees. Okay. Now let's do a second equation. Let's look at this outside triangle. You might remember an example from the previous video where we had this situation with the two triangles. Okay? If you don't remember it, go back to the video solving right triangles, extra examples. Okay, so tan of 42.67 degrees equals opposite over adjacent, which is that long side here, h over 33 plus x. So from this equation, we get 33 plus x times tan 42.67. Okay, so I got two equations. This tells me h is equal to that expression right here. The second one is telling me h equals this other expression right here. So that means these two expressions, this guy and this guy, those must be equal to each other. Okay? So now we're going to solve for x in this equation. X times tangent of 47.5 degrees equals 33 plus x tan 42.67. All right, now you're going to need to think about your algebra. This is a linear equation in the variable x. Notice it just has x to the first. How do you solve a linear equation? Well, you get every term that has that variable on one side. Get every term that doesn't have that variable to the other side. So in other words, I want to be able to move this x over here to the left. Now I can't quite move this x right now because you got the parentheses. So it's like the 33 and the x are stuck together by those parentheses. So how can I get rid of the parentheses? Well, I should distribute on the left-hand side. So I have x tan 47.5 equals 33 times tan 42.67 plus x times tan 42.67 degrees. Now I can take this and subtract it from both sides. X times tan 47.5 degrees minus x times tan 42.67 degrees equals 33 times tan 42.67 degrees. All right, now I've got all the x terms on one side. What I'm going to do now is factor out my x. Okay, so I'm factoring out my x. Okay, so that's taken out. And now I'm going to solve for x using some division. 33 times tan 42.67 over this. Okay, we know x times this is equal to 33 times tan 42.67. So we take that and we divide both sides by what's in parentheses right there. On the left-hand side, it cancels out. And on the right-hand side, we get this. Okay, so now this is something we can compute on our calculator. It's a couple of steps, but we can compute it on our calculator. So that gives us the value of x. Then take that value and plug it back in here and finally get h. Okay, so there's still one more step to do once we've got this. So this is one of the more complicated kind of examples that you'll encounter in the application section, because we didn't really know either length. Both of the side lengths involve unknowns. So the technique is, if you got unknowns on both sides, set up two equations and then set them equal to each other and then do your solving, okay? So the idea with applications is figure out ways to get triangles into the picture and then use the information, use the techniques that we discussed in the videos on solving right triangles to get the extra information that you're looking for in the applied problem.